So as we are looking at OSPF and preparation for our exam, make sure you do all the labs on NetLabs. Those labs are extremely important. With BGP, you may just want to bite down and do just simple neighbor relationships and understanding how the best path is selected in BGP. But in OSPF, you really need to know a great deal about what is going on with OSPF. The fact that it is obviously a link state routing protocol, that it does perform neighbor relationships, and it has a neighbor table, it has an adjacency table, a neighbor table, which is adjacency table, a topology table, and then a routing table. And all of those are extremely important. Now, when we get into multi-area OSPF, one of the things we need to think about, oops, that's my presentation for tomorrow. One of the things we need to think about is how each OSPF area works and how it is set up. Now, to begin with, an area is a logical group of routers that you put together, and the purpose is to try to limit the link state advertisements that get sent between areas. Now, the funny thing is, if you break your network into areas to begin with, so using my whiteboard example here, actually, where did I put my whiteboard? Here it is. My whiteboard example here, if I've got 3 different areas, area 1, 2, and area 0, by default, if I set this up, it really is still what's gonna happen is inside of each one of these areas. Now, what type of area, what type of link state advertisements stay inside areas only and do not travel between areas? Michelle, can you give me what that is? What type?
Is it LSUs?
No, link state updates. Link state updates can travel between, depending on what, well, I think about this. They would stay within, but there's a certain type. When we talk about LSAs, an LSA type 1, which is a link LSA. That is where the router in this area looks at all of its links. So let's imagine that all of these are on loopbacks here. So I'm just going to put out here multiple loopbacks. Type 1 LSAs are used in an area by the router to tell all other routers in that area about its directly connected links. Now, what happens with those type 1 LSAs depends on the type of network you're on. If it's a multi-access network, such as 2 different types, either Ethernet or possibly non-broadcast multi-access like frame relay, there is a DR-BDR election. And that is where we will have LSA type 2s. And those are used by DRs. And what they do is they take all the type 1 LSAs, convert them to type 2 LSAs, and flood them into the area. But these 2 types of LSAs will not leave the area in which they are created. So a type 1 LSA will never leave the area. What is this router called here that sits between area 0 and area 2? Debu, what's that called?
Area border router.
Area border router.
Right. So this is an area border router, ABR, an area border router. ABRs use LSA type 3s, which are called summary LSAs. And it's funny because they're called summary LSAs, but they're not really summary LSAs. They're actually, sorry. Sometimes my hand does that and I get, I've hit the button, let me unbutton the button. So they're summary LSAs. And summary LSAs, come on now, stop, are the networks that has learned inside of the area that then get passed into other areas. Now, here's the bad thing. By default, it's really not a summary. So all of these networks, if you had 4, 5, 6, 7, and 8 in area 2, would all be listed over in area 1 as an external not external, but an inter-area route, an IA, because it's between different areas, not intra. Intra is within. That's just an O route within. Now there's two other types that we have here, and those are type 4 and type 5s, and those are used primarily by, let me roll down here to my types here. Oops, I don't know how that got messed up. Should not have been. Let's see if I can make some room here. Let me pull this over here. So type 1 LSAs, each of the router links does not leave an area. Link states, network generate these. If they're a DR, they take the type 1s, convert them to type 2s, and then send them out in a multi-access network. Type 3s are summary areas, summary LSAs, and they're not, funny thing is by default, they're not really summaries. They actually carry all the network information in the network. Then you've got ASBR, Autonomous System Boundary Routers. And this is typically any route that is being redistributed into your network. Now, the funny thing is, a lot of times you'll read these as autonomous system border routers, but the technical term is boundary routers. And then type 5 is external routes. This is typically what we see when we're doing our external default route that gets sent into OSPF, and that's where your OE2 route shows up. And then there are other types such as not so stubby, stubby, just there's all kind of, there's 6 through 11, obviously. So there's a lot more packet types, but these packet types all exist in the network for different functions. How do I keep clicking this in? I mean, be over here. Okay. So in the area, each one of these areas, you will see here, the idea is to reduce the size of the tables. The other area, the problem, you see this here, this is a problem because there's no area 0. But one of the problems is, even if you do take your network and break them into areas like this, unless you summarize at your area border routers, a route going down on one of these loopbacks would still cause an SPF calculation in the other areas because that route would be removed. We're going to talk about how you can summarize on your border routers, and that is part of this particular chapter. Now, true false, area 0 has to be on every single instance of OSPF.
False.
That's actually true. There must always be an area 0 in OSPF. It's called the backbone. The other item that is normally said is this. Typically, we've got area 0 here. Typically, we are required to always have every other area directly connect to area 0. And by design, it is suggested that areas don't connect to one another. They only connect to area 0. This is completely and totally past what's in this class. This is what's in the ENARSI class. But there is actually a way to come out here and have, let's say there's a router here. It's right here. All right. And let's say there's another area here. Let's say this area right out here, for whatever reason, is area 31, A31, okay? Now, it's not directly connected to area 0, but what you actually do is you create what's called a virtual link through area 2 back to area 0, which makes area 31 think it is connected directly to area 0. This is a poor design practice, and it's not covered in the class, but I want you to be aware of it, because if you go in a couple of months from now and start reading about virtual links, and you say, well, Kelly told me you couldn't have an area that wasn't connected to area 0. Well, technically you can, but it is highly frowned upon. So it's not something that's suggested in network design. But
Kelly,
go ahead.
I'd like to ask a question. If you're going to configure OSPF in multiple areas, then you need an area 0. But if you only do it in one area, you don't need an area 0. That it can be any area. Is that correct? No,
it has to be area 0.
Has to be. If it's only one area, it has to be area 0.
Yes.
Okay.
Yes.
My next question,
area 0.
And my last question is a Halabi book still relevant for BGP?
The what?
The Halabi.
The book?
Yeah.
Yes. Yes.
Okay.
Yeah. BGP hadn't changed in forever.
Okay.
Yeah, that book is good. That's a very good book. Also, I think I sent y'all the thing with Dr. Krachenko down at USC. There's going to be a 2-day session where one day is perf sonar and other items, and then one day is looking at BGP. That's going to be a good little item, because that is looking at BGP, and it's looking at open BGP, and basically BGP is an open standard. So yes, yeah, that book is very good, but that book goes into much more detail than what you're going to need for this class. Now, it will be useful for the next class when we get to NARSI. But your first area should always be area 0. All right. Now, this process ID, again, is just a process ID. It does not have to match. One of the things that I have learned recently is that for network automation purposes, they actually recommend that your process IDs increment based upon your router. So R1 is OSPF 1, R2 is OSPF 2, 3, OSPF 3, but do it sequentially. And the reason being something to do with DNA center and network automation. It makes it easier to do network automation if you have process IDs on your OSPF that are incremental or increment. So you'll see here assigning networks to different areas. This, by the way, is OSPF version 2, which is only supporting IPv4. We're going to talk about OSPF version 3, and you will need to know how to configure that. So our area IDs here, you see it's from 32-bit field, so 0 to 4 billion plus are different areas. And we can look at our different types of routes here. And O is an area that is inside your area. So that's an intra-area route. And OIA is an inter-area route. So that is a route that is learned from another area. Okay. So intra-area routes versus intra versus inter-area routes. And each one of these routers in between the different areas are area border routers. Okay. So here again, we're showing more. We're looking at the different route tables here, looking at different metrics. Routing table shows routes from area 1, 2, 3, and 0 as intra-area routes, and area 56 is an inter-area route. Because all 4 does not connect to area 56, the metric for those networks is drastically increased compared to the metric to the 56 network, because 56 is local versus the other. Move on down here, a couple things. One of the things we will learn is that as you're doing link state advertisements and announcements, the process that happens is many times you'll send a database summary with a type, a database descriptor packet, and then you'll do link state requests to find out about certain networks. You'll get link state updates, and then those can be ACKed. Eventually, though, all routers in an OSPF network should have a common understanding of the entire network, which is very different than any other protocol we've looked at, because EIGRP, even though it is carrying a topology table, it only learns from its other neighbors. OSPF learns from all the other routers in its area and other areas, the complete picture of the network. So here's our LSAs again. Type 1 advertises LSAs that originate within an area. Type 2 LSAs are the basically the DR takes all the type 1 LSAs it receives from those routers that have established an adjacency with it and turns back around and sends them out as type 2, so that the network's not flooded with more type 1 LSAs than are necessary. Type 3 advertise prefixes originating from a different area, and that is a little bit confusing because they call it a summary LSA, although it doesn't by default summarize. We'll learn how to do that here in a second. Same thing here, ASBR advertises summary LSA for a specific autonomous system border or boundary router. And then these are routes that have been redistributed. So these two can be redistributed routes, or they can be an entire different instance of a routing protocol, or they could even be, it could be static routes, but typically redistributed routes end up being type 5, they end up being external routes. And these are routes for not so stubby areas, and I keep seeing it in everything I'm reading. So for some reason, they want you to know that a type 7 is for not so stubby areas, and that is a Cisco proprietary area. Typically, stub areas are areas in OSPF that only use a default route to get out and do not make the network aware of all the networks inside of it. Not so stubby area is a Cisco proprietary. But here you can see your LSA components. If you do a look inside of one, you can see its type, LSA router LSA, who advertised it, how old it is, and the metrics, those types of things that are inside of there. So not going to spend a lot of time here, but here's your type 1 LSA staying within their area. They will not go across and leave this area at all. If you do a show IP OSPF database router, you will see the type 1 LSAs that have been advertised inside that network. Type 2 LSAs, again, those are ones that are brought in as the DR. They take the type 1 LSAs and they convert them into type 2s, basically. Type 3 is your summary. So this is taking all the type 1 LSAs and the information that the area border router has brought in and sending that information about those networks and prefixes to other areas. So those type 3 LSAs do go between different areas. All right. Again, discontiguous networks are not, this would not work because you have a discontiguous network backbone and you end up with major issues because they believe there's 2 different backbone areas, and that would cause a lot of problems, and it's not something that should be done. Here are the 3 rules for an area border router creating type 3 LSAs. Type 1 LSAs from the area create type 3 LSAs into the backbone and non-backbone areas. Type 3 LSAs received from area 0 are created for the non-backbone area, and then those received for non-backbone area are only inserted into LinkState database for the source area. So ABRs do not create a type 3 LSA for other areas. So when it comes into the area 0 will send type 3 LSAs to the other area border routers, and then those will be sent to inside of their network. But discontiguous networks, just don't do it. It's very bad, very, very bad network design. What is the metric for OSPF? What determines the best path? Cost. Okay. How is that cost figured? Can anybody remember anybody know?
10 to the 7.
It's 10 to the 7th divided by the bandwidth in bits per second, and that gives you your reference bandwidth. Now, by default, okay, let's go in here, and I'll have to do some work here. Actually, everybody, you can all go in this router with me. This is a special thing. If you log in right now to Netacad, you should, or not Netacad, NetLabs, you should actually be able to all get in this router with me, which is pretty cool. I've actually done a class reservation. So lab 913 R1. So let's control A, and remember I've given you every one of the starting configs for these. So all you have to do is go in here and copy and paste them in using this method. You don't have to sit there and type in all of that starting config, which is a huge time saver. And at this point in your networking career, this is the type of stuff that you should be able to, you want to be able to do and make happen quickly for yourself, because we've got enough to do with the route, with the labs as they are. How many people have done this lab so far? Any of you? No, 1 or 2 of you have, because I've seen a couple of you working on this one. Or
I think I have.
I think you have too. I've seen several of you are on this one.
I have.
Yeah, I think you have. Let me get back in here on this one. You really don't even need the PCs on this particular one. It's a D2. See. Go in here and paste the terminal.
Didn't you have to reset that?
So what?
Didn't you have to reset? That's the switch, right?
Yeah, this is D2. I haven't set D1 yet.
Oh, okay.
Yeah, D1 hadn't been set yet. So I've got R1 going. So Control Z, let's do this. First off, what command can I use to show my neighbors, my OSPF neighbors?
Show IP OSPF neighbor.
Okay. Show IP OSPF neighbor. And you can see that I've got one neighbor. So let's pull our topology up and see here. So R1 at this point right now has one neighbor, which should be, looks like probably R2. Yep, which is R2. It's a full, and you'll notice that R2 is the designated router for this area, which is, by the way, now I can do this. I can do show IP OSPF database. And I will be able to see that in area 0, here are the link. Okay, so here are the type 1 LSAs that I have received. Here are the type 3, excuse me, down here are the type 3 LSAs I have received. These are the type 2s. Okay, and down here we can see the link states for, this is type 1 for area 1, and on down we can see other ones we have available. Now notice here, when I see this in the database, I'm going to be able to know that if I do a show IP route, I'm going to have an OE2, okay? Because in the database, I can see this external link that's being advertised by 2221. Also, you'll notice that I've got this route, 10.10.40, which is an inter-area route, which should be 10.10.40 coming off of D2. So you can see that I have connectivity. Now, what is this O route right here? Looking at this routing table, what would I be able to say from that route?
It's an OSPF route.
It's a route from an area that this router is part of, okay? Because it's an intra-area route. So looking at R1, you can see that that's either going to be part of area 0 or part of area 1. And this particular route is part of area 1, looks like. Nope, is that area 0? Area 0. So that's part of area 0. I should have a 10.10. I'm connected to it, so I'm not seeing that one. The connected one here. On D1, the router is not running OSPF at the moment, or it's not running. Actually, let's do this. Show IP OSPF neighbor. You'll notice I don't have a neighbor relationship with D1 yet. So D1 has not been configured with OSPF. So let's go. Anybody else logged in here? Because I'm gonna let y'all do some of the typing.
I am.
Okay, go to D1. Let's all go to D1. Let's imagine I just drop you in front of this router, Corey, and say, I want you to configure OSPF for me on this. Now, you've got your topology, so you've got your topology. But let's imagine it's for some reason you didn't have your topology. What would you, well, you know you got to be, one thing you've got to know your area. So you know you're going to be in area 1. So that's pretty much a given now, I'll tell you that. But what would be one of the things you would want to do first?
Set up OSPF.
Set up OSPF. Now, something went wrong here because it's saying it's trying. Let's look. First off, give me the command to look at what routing protocols are on this particular switch already.
Show IP route.
Show IP route. Show IP protocol.
Show IP protocol. I would do show IP protocol. So do show IP protocol here. Remember, we're in config mode, so this will let us skip having to drop out. All right. So it looks like nothing is currently configured. Now I need to check something because it looks to me like D1 was supposed to have something configured. Nope, it does not have anything set up. Now they have the point-to-point set up here, but they don't have OSPF set up. So let's turn on OSPF. So what would be my first step? Okay, now let's do OSPF version 2. Don't use OSPF version 3.
Is it OSPF version 2 default?
Yes.
And then our area
Router
is what?
OSPF.
You got to do router
process-
OSPF. So do router OSPF.
Router OSPF.
Yep, router OSPF. And then for process ID, pick whatever you want. Just do 1's fine. Okay. Why did this bark at you and tell you it's not enabled?
We have it enabled routing on the layer 3 switch.
Exactly. This is a layer 3 switch. So enable IP routing. Let me show you a nasty trick real quick. I want to show you all this. If you really want to mess with your students, you can go in here and do a no IP routing on a router. That's mean, but it's fun. Okay, sorry. All right, go ahead.
This is just IP
space routing. IP space routing turns on routing. Okay. So now let's do router Ospf 1. There you go. Let's give it a router ID. Let me pull the content up here because I think it gives us a router ID. I think it's 222. Oh, let me check. Can't remember what they want us to do. On D1, it's 1112. So let's do 1112. 1112. Okay. Now, what's the easiest way to turn on all? There's multiple ways now to do this. So, Clay, what is one way we could do a network statement? First off, what I'm going to show you is this. I would probably, if I was on this router, do a do show IP int brief. So I see what networks are on my network. So I've got the 10.10.02. I've got those. So I also obviously can look at my topology and look at my content. I've got these 4 networks on my switch. So one way I could do a network statement would be a single network statement for one of our configured networks. So let's do the network statement for the 10.10.20/24 loopback. So go ahead, Corey, do that one for 10.10.
It's going to be network 10.10.21 or 10.10.20.
Right.
Area 1.
You've got to put a mask in. So network, you got to put a wildcard mask in typically, but now true false. In the real world, we can put in subnet mask and it will convert for us. That's true. Now the actual command, you're supposed to use wildcard mask. Yep, area 1. Good. Okay, so we're in area 1. So that's one way we could do this. All right, easy to do. What's another way that I could have done this that I taught y'all to get every single one of your networks?
Network 0.0.0.
000 quad 255s. But let's go ahead and do 2 more network statements. So easiest thing to do here is hit the up arrow. Just hit the up arrow. Oh, sorry, I messed up. Hit the up arrow. And just go back and do 10.3 or 3. And then we've got to do the one more, which actually I'll type this and do the one for 10.10.00/30. What would that be? So that's our connection up to R1 right here, which is a /30.
10.10.
You looking for the wildcard mask?
Yeah, what would be the wildcard mask for a /30?
It's a point to point, right?
Yeah,
It's 0003.
correct. That is correct. So 10.10.0.0 and then 0003 area 1. All right, it's gonna bark at you because Nick Ward, but let me show you a trick. Hold on one second. Let me make sure y'all are aware of this. Next time, all right, go ahead and hit enter. If I hit the up arrow, if I hit Control A, it goes all the way to the beginning. Control E goes all the way to the end. Don't forget that little trick. So now let's drop out of here. Show me someone else want to take over. Clay, is anybody else in here? Anybody else inside of the lab with us? Clay or anybody? It's just Corey.
I'm there.
Okay, Michelle, show me my neighbors.
Okay, hold on. Let me get back over here. I'm in R1. I need to be in D1.
D1, correct. Being
Okay.
D1.
All right, hold on. Okay.
There you go. So we'll see we have a neighbor relationship with 1.1.1.1. It is the DR. So more than likely we're the BDR. Run this command for me. Show IP OSPF. All right, we get a lot of information here. Notice we're going to see, I'm going to scroll back up for us. You're going to see that this is process ID we get. This is my current router ID, which we've hard set. Quick question for you, everyone. What is the router ID if we don't hard set it?
Is it the highest IP address of a loopback?
Highest IP address on a loopback, if you have one on a loopback, or the highest IP address on a physical interface.
Okay.
One of the things that I've recently read about, a best practice is actually to set your ID to the same as a loopback that you have set on your machine. Also, one of the best practices I recently read about, one of the best practices I recently read about was that loopback that you use for your ID should actually be an address you can get to, which is kind of wild. The other thing to be careful with, and I've seen this on several questions, so I don't know why they stress this, but if you don't change the type of a loopback, by default, I'll show you what happens here in just a second. The OSPF shows it as a loopback and will only advertise it with a /32. If you make it a point-to-point like they have done in this example lab, it will actually advertise the actual mask that's on that particular interface. But if it's a loopback and you don't set it to be point-to-point, it will be a loopback and it will go out as the /32. But notice down here, we found what areas we are part of. I have 3 interfaces in this area. It has no authentication. So down the road, when we start doing authentication in areas, this would be where you could see what type of authentication is available. And you can also see the checksums. Okay. Do a show IP OSPF route. So
Okay,
show,
let me get back over there.
okay. Show IP OSPF route.
Oh, okay. There is no.
Not showing
What?
it, is it? Okay.
Nah.
Show IP OSPF. Show. Now I can do route OSPF. And that'll show us all of our current routes that we have. And you see we've got the inter area routes that are from other areas. Show IP OSPF. Oh, okay. Show OSPF. Nope. Notice there's our virtual links information. Just drawing a blank on the command. But let's do route OSPF and look at our route. So we've got our routes here. We've got this external route. So that is a type 5 that's been advertised into this area. And we got our 2 intra or inter area routes here. There are no intra area routes. There are no just O's that are being advertised. So we've got nothing coming in from R1. So this router is up and running pretty much and is running OSPF. Let's go over to D2 and let's do a do show IP prot. You'll notice it's not running, so let's turn on IP routing. Let's do a router OSPF1. Oop, can't spell it. OSPF1. And I'm going to cheat here. Do show IP brief. I'm actually going to cheat and just do a, there's all of our loopbacks. I'm going to do the network. Actually, I can do my router ID first. Router ID. And I got to go remember what they want this one to be. E2 3332. So 3.3.3.2. And so we're going to cheat and just do network quad 0. Area 2. Okay. Make sure I got the area right, which it did. And we've got our full status here. So let's do a do show IP OSPF neighbors. You'll see we've got a neighbor relationship with R3. Go over to R2 now, and we do a do show IP route OSPF. We should see a bunch of routes. And notice how we've got all these 16, 17, 18, 19, 20, 21, 22. Now, so you'll notice all of these are type 3 LSAs that D2 is telling R3 about all of these loopback networks. R3 is taking those, converting them to type 3 LSAs and putting them into area 0. And so they're all coming into area 0. And then we go all the way over to D1. And if I do the same command over here, you will see now we've got all of these inter-area routes, 16 through 23, coming from area 2. And again, it's funny because these are called, quote, summary routes, but they're not really summary routes. So we need a way on the area border router to summarize, okay? And there's multiple ways we can do this. Let me go down here and show you. By the way, here's our reference bandwidth cost. Make sure you do know how to change the reference bandwidth to where a gigabit Ethernet, the default reference bandwidth, by the way, makes a fast Ethernet, gigabit, and 10 gigabit all cost 1. If you want a gigabit to be a reference, you set the reference bandwidth to 1000. If you want 10 gigabit to be a reference, you set it all reference bandwidths to 10,000. But when you set this, it's set, and you need to set it for every single OSPF router in your environment. But down here, a couple ways we can do summarization or aggregation. One is we can do the area range command on area border router. So what this will do is it will create a summary LSA, a true summary LSA, and it will summarize your type 3 LSAs. Okay, let's do this method first. So let's go back over to our environment here. Let's go all the way over to R3, because if you look, R3 is the area border router for area 2, where these routes are coming into the other areas from. So we're going to create an area range on R3. Now, how do we do that? How do we create a range? First off, we need to look at what we want to summarize. We want to summarize 16 through 23. So what we need to do is open a new notepad. And do any of you remember how to summarize? So we know we've got, basically you know that 10.10 is going to summarize to, we know that all those are matching. But now we've got to summarize from 16.0 all the way down to 23.0. You remember how to summarize?
Yeah, we just use the lowest and the highest and compare the bits for the octet that's different.
Exactly. So what we're going to do is we're going to look right here on the third octet, and let's put 16 in binary. 128, 64, 32, 16, 8, 4, 2, 1, 17, 1, 2, 3, 4, all the way down to, there's 18, and we'll go all the way down to 23, which should be 0010 1111. Wait a minute, I'm missing a 0 there. That is correct, I believe. Okay, so 16, 4, 20, 22, 23. So this is 23. Now we need to find the bits that match, and we can see here that we match 5 bits here. So to summarize from 16 to 23, we would have to have a route that matched the SuperNet 10.10.16.0 slash 16, 17, 18, 19, 20, 21 slash 21. Okay. So we're going to, this is the summary route for 16 through 23. So we'll go back into R3. We'll go into router, OSPF. Let's make sure first off, do show IP pro. Let's make sure they used 1 as their, nope, they use 123 as their process ID. So it's important to know that. So go router, OSPF 123, area 2 range. Okay, question mark. We'll put in the beginning of our summary. So 10.10.16.0. You'll see now the mask for it,
255.248.
248.0. And hit enter. Now let's go do some looking around and see what just happened. So let's go here. You see we had 16 through 23 here. Now we don't have that anymore. Now we have 16 /21. So where we had all those routes before, now we're able to use many fewer routes. Same thing on R2 inside of here. R2 now has many fewer routes. Okay. And even on R3, the cool thing about R3 is do show IP route. Yeah. I figured out my command, by the way. I forgot. But you'll notice there's now a null 0 route for our summary. And that is in case for some reason something comes into one of these and that's not up, it will be dumped in the bit bucket. And that's a function of creating a summary route. All right. So that is one of the processes you can use to do summary aggregation at the area border router. Okay. You can do the exact same thing at an autonomous system boundary router, but with the summary address command. And that summarizes multiple type 5 LSAs. We then have two other methods, really three other methods, to control aggregation and route summarization. One is an item called a distribute list. Now, distribute lists are not for keeping routes going into other areas. All a distribute list does is keeps a route from going into the local router's routing table. So distribute lists are to stop them from going into a routing table. Prefix lists actually are used to stop them from going into advertisements. So with a prefix list, instead of summarizing all these together, if I wanted to block just a single route, I could actually block a single route. And with the prefix list, you build the list, set your match state or make your match statements, and then determine your set statements. That's what you do with a prefix list. And then a route map is where we're really getting into some, excuse me, that's a route map. You do route map, match actions, and then set actions. So the route maps, we can then actually control redistribution, policy-based routing, and they're used a lot with BGP. Each one of these is covered. I don't know the route. Yeah, the route map's covered in this lab. So if you'll do this lab right here, 913, you will actually get all of these items that are part of the summarization. So we got summarization, which we just did. And then another thing we can do is this. This is kind of a wild way to do it. You'll notice that we have do have this /21, but I could actually do this over here on R3. I could, instead of doing area 2 range, I could change this to say not advertised. And this will now actually block all those routes. There will no longer be a route to any of those networks that we were advertising. So no 10, 10, 16, 17, 18, all of those are now gone from area 3. Area 3 is no longer advertising all of those. And that was simply by putting the not advertised at the end of our range command. Now, if I go up here and hit a Control A again and put no in front of it, you'll notice very quickly, all of our routes come back. All right. So let's say I only wanted to keep the 18 network from being advertised. I could actually do it with an area range command. I give area 2 range 10, 10, 18 dot, oops, 18.0, 255, 255, 255.0, not advertised. If you go back here on R1, 18 is now gone. So that is a way to do it. But you can also do that with a prefix list or with a route map, either one. You can do either one of those. So this lab does go through and have you do each one of those, how to block, how to do summarization, how to do route filtering. Okay. And they do that with both a prefix list, and they go in and use a distribute list. The big thing about a distribute list is to keep it from going in that local router's routing table, whereas a prefix list and the other methods are to keep them from going into other areas and being advertised across those areas. All right. God, I keep clicking the wrong thing. By the way, I'm doing a presentation on Tinkercad or on microbits in two days. So here's our summary routes, fundamentals, talking about those. And again, it's just pretty much showing you the different ways of doing summarization. Oh, one thing I want to show you. I do want to show you this because I remember this was something that was had showed up on a bunch of different items. Okay, so R1 and R2 in our topology are connected via gig 000, gig 000. So R1, R2, if I do a show IP OSPF neighbor, you'll see that I have a neighbor relationship with 2221. Okay, and it's full DR. If let's go config T, int G000. If for some reason there is a mismatched MTU between two neighbors, you'll notice what's happening here. Notice my dead time. Okay, so we're going through there. What's going to actually end up happening is here in 30 something seconds, I'm going to lose my neighbor relationship with 2. I should. Let's do it. Do clear IP OSPF process. I should get stuck. That's exactly what should happen. If there's a mismatched MTU, you will be stuck in XStart. You cannot form a neighbor relationship if you don't have the same MTU on the link. And it has to do with fragmentation and the fact that OSPF does not handle the fragmentation bit well. So if you get an item and you're troubleshooting and you see that the routers have XStart between them, you may want to go into the interface and check the MTU. By the way, the way to do that is do show int G000. And the MTU should be in here. I gotta find it. Oh, where is it? I can't remember. Anybody remember how to see the MTU? Nope.
Shouldn't we just look at the interface itself?
Well, you can do that, but I'm trying to do it without having to do a show run. Because that's not really a troubleshooting command. Show interface MTU. Yeah, that's easy enough. Show interface. Here, let me drop out of here so I can show interface MTU. Show. All right, so that's not working. You notice here that it keeps trying XStart to down, XStart to down.
So when we look at the interface, the show interface and type its name and number, it won't show us the MTU.
Show int G000. I did not see it there. Oh, there it is, 1500. Nope, it says 1500, but that's not. Hold on a minute. Do show. Int. It does show it, but I've changed it, so it's not showing that I changed it. Now that is very wild. So if someone has actually done a change to the MTU on the interface, and that's probably why they make this one of their troubleshooting items that they show to everyone. Well, see, the MTU is different here, but it is not showing it as different when you run the command. That is wild. Okay. But you can see this by looking at the fact that it is in XStart mode. So if you fix this, int G0. 0. You fix it, you will almost immediately, that won't be immediate, but you will get a full neighbor relationship. Yep, there it goes. Now you have your neighbor back. So just be aware, that's something I've been reading a lot about, is that if you have a mismatched MTU, you cannot form a neighbor relationship across a link. Okay. Let's see, anything else I want to cover on OSPF before we get away from it? You do need to know about OSPF version 3 and the fact that OSPF version 3, you'll notice that our traditional method for OSPF is writer OSPF process ID, and that is all version 2 for IPv4. If you're doing IPv6, OSPF version 3 for IPv6 only, you can use the IPv6 router OSPF process ID and then put the links into the areas. However, there is a new way where you can do router OSPF v3 process ID and then use address families. The problem with this one is it will not pair with traditional OSPF version 2 routers, but this is the preferred method now that we can do address families. So we can actually go in and set up an address family for v4 and put the commands under it, like passive interfaces and those types of things, and then also for IPv6. So any questions on this lab or what we've gone over today with OSPF? Next class, we will knock out BGP, and we will take a look at what BGP and what we need to know about BGP. Any questions at all?
No, sir.
All right, sounds great then, everybody. Thank you so much. If you have any questions, let me know. Send me some emails. Otherwise, keep working, and we'll work on getting our BGP on next week and then go on from there. Thanks, everybody. Let me turn off recording.